In this lab, we're going to be looking at double displacement reactions. Very specifically, you've been learning about how when two ionic systems react with each other, if they react, they can generate precipitates, they can generate gases, liquids, solids, or there could be no reaction at all. And a lot of the decision is whether or not you'll actually see reactions based on solubility. In this lab, what we're going to do is we're going to run through a series of different binary reactions where we're basically going to take two individual ionic systems and we're going to put them in the same test tube and see what happens. As we go through this, you can pause and you can try to predict what you think will happen based on your understanding of double displacement reactions, or you can basically just watch the reaction and try to determine how or why or what the products are, what the net ionic reaction is, and so forth. So the first pair we're going to look at is we're going to look at sodium chloride and potassium nitrate solutions. So we have a 0.1 m sodium chloride solution and we have a 1 m potassium nitrate solution. So if we just move those into shot for you can see. And of course I'm wearing gloves simply because we're going to be using a lot of different chemicals today, and so I want to make sure that I am safe. Even though some of these are fairly benign, like sodium chloride solution, of course, we want to be careful when we get to things like iron nitrate systems that are toxic. And so you should definitely look through the list of reactants before you start any reaction and make sure that you are in fact going to do this safely. So we're going to start by adding about 1.5 ml of each of these systems into a test tube. So we're going to pick one test tube. We're just going to start on the left here in the front rack. And I'm going to add about 1.5 ml, so about a pipette full of that material to the first test tube. And I'm going to use disposable pipettes for all of this because we're going to be going through quite a lot of samples. I'm going to keep them associated with the sample. We don't want any cross-contamination, so we're not going to reuse the same pipette for a different material. Now we're going to add the potassium nitrate system. And we'll see what's going to happen here. What you can see when I added those two together, just give it a little shake so you can see, and we'll bring that into focus for you. So we have two clear solutions that we added, and this is what was generated when we added them together. So not a particularly exciting system, but you can now write down whether or not you saw a reaction, whether or not you believe there was no reaction there. We're going to put those aside. The next system we're going to do is we're going to look at sodium chloride and silver nitrate. So we'll bring the sodium chloride back and we'll bring also silver nitrate into shot. So you should be careful with silver nitrate. Silver nitrate is toxic, but beyond that, if you got this on your skin, it would actually turn it black. You get these like black spots or black dots where the silver nitrate hits. So you have to be very careful with that. Even when you've got gloves on, if you've got open arms like I have right now, then you should just be careful not to splash it everywhere. So we're going to add the same thing. We're going to add about 1.5 ml of the sodium chloride system into our test tube. Notice how after I'm done each time I put the lids on. So this is just a good lab habit. If you take the lid off of a system, make sure that you put the lid back on. Just prevent spills. You know, if you spill silver nitrate everywhere, it's going to cause quite a mess. You want to avoid that. So now what we're going to do is I'm going to try and do this in focus for you. So if I take the silver nitrate and I add about 1.5 ml of that to our system, you can see that it turns milky, and if you were watching closely you probably saw what was happening inside that liquid. You probably saw a solid being formed, and that's what sort of dissipated throughout that liquid. So the addition of silver nitrate to sodium chloride gives you some kind of a reaction, so you should be writing down what you think that reaction is, whether you thought you saw a solid, a liquid, or a gas formed. I can tell you that both of these are the same temperature to the touch, so there's been no change in temperature. And that's a really important aspect of reactions and observations in general. A lot of times people are looking for things they can physically observe, watching a gas evolve through bubbles, watching a solid form through a precipitate, even seeing a second layer of a liquid forming. But one of the ones that's often overlooked is temperature. If a reaction occurs, sometimes it may look like this first one looks clear, looks like nothing happened, but the bottom of the test tube itself may feel warm. A change in temperature indicates that a reaction did indeed occur, and you should make a note of that. So we're going to keep working through this, but we're going to keep an eye on all of those observations as we go. In the third test tube, the third reaction we're going to run, we're going to take sodium carbonate and we're going to add to it 6M hydrochloric acid. So we have our sodium carbonate, and we also have our 6M hydrochloric acid. I'm going to add the sodium carbonate first. And we're simply, and when you add, remember when you're transferring liquids, you try to keep the mouths of the containers close to each other like this, so that you only have a very short distance. You don't want to be like carrying it over books and long distances. You want to just be able to like put your pipette in, get the material that you need, and with the mouth of the other vessel being very close, it's a very short transition period, less likely to put drips all over the place. And now we've added our sodium carbonate. We're not going to reuse that. We're going to use a different pipette for the 6M HCl. And we're going to use the same transfer method. And I'm going to try and put the test tube in shot for you so you can see what's going on. I'm just going to add this to the sodium carbonate. And what you can see there is those bubbles that you see down there are not just mixing bubbles. There actually was a reaction. Now if you look carefully, there's also a little bit of condensation. Sorry, to get a lot of shot there. It's kind of hard to see, but right here there's a little bit of condensation too, like some water evaporated and cooled on the side of the test tube. And I can tell you that to the touch, yeah, it's a little bit warm, but not that warm. So even though we didn't see any physical reaction there, no solid was formed, it did look like there were bubbles formed. That wasn't just from the mix. So if we look a little closer at that, those bubbles have held. So that tells you those bubbles were probably formed during the mixing of that system. Our fourth pair that we're going to work with is sodium hydroxide. We're going to use like a 10% or a 0.1M actually sodium hydroxide system and a 6M HCl. So I'm just going to switch out the sodium carbonate. I'm going to use a 0.1M sodium hydroxide reaction. So the first thing we're going to do, we're going to get ourselves a clean test tube, and we're going to transfer in the sodium hydroxide. Same way we did before, keep the mouths close to each other so that's a short transition period. Put the lid back on the container, and then we'll get the HCl, and we'll try to keep that test tube in shot as we add the HCl. So I'm using the same method as I was a few minutes ago. The mouths are close together. I'm just adding this on the side so you can see it better. So it's a little bit cloudy when it goes in. And the bottom feels just a little bit warm. Not excruciatingly warm, but definitely above room temperature. It's slightly cloudy, so there may be a reaction going on there. I wouldn't have anticipated much cloudiness in that one, so maybe there was an impurity in the bottom of that test tube. We'll come back and check on that in a little while. The next pair we're going to look at is we're going to look at barium chloride, and we're going to mix that with the 3M sulfuric acid system. So we're going to move these ones out of the way. We're going to get our barium chloride system and 3M sulfuric acid. We're going to add the barium chloride. And then we're going to add our sulfuric acid. I'm going to try and keep the test tube in shot as we add the second component so you can see what happens clearly. But I'm using the same technique as I did adding any other liquid to the test tube. And you can see as soon as we add that, there's clearly a reaction occurring. It's for you to determine what you thought you saw there. Most times when we see like a milkiness like that, we're basically forming a solid inside of a liquid system. Kind of like milk is, right? Milk is basically milk fat suspended in this aqueous system. You're seeing the same kind of things here. If I pick up reaction B that we did a little while ago, you can see there's actually solid beginning to settle out at the bottom of it now. So we can confirm indeed there was actually a solid formed there. If we look back at this one, which is set E, the fifth set, it's still kind of milky and suspended, but that will probably change with time. So when we reacted the barium chloride and the sulfuric acid system, we found a solid forming. And so we're going to put the barium chloride away. And we're going to use a 6M ammonium hydroxide. So if you haven't seen concentration yet, the M, or molarity, or molar, is a statement of how concentrated the system is. The higher the number, the more concentrated it is. The ammonium hydroxide is a 6M. The sulfuric acid is a 3M. And so we have to be careful with this one because we're using two fairly concentrated systems. Typically what I would do is I will add the more concentrated to the least concentrated. So the first thing I'm going to do is I'm going to add the sulfuric acid into our system. And then what I'm going to do is I'm going to get the ammonium hydroxide. I'm going to try and keep the test tube in shot again, so I have a clean pipette here. I'm going to try and add this in shot for you so you can see what happens when we add the ammonium hydroxide to, so 6M ammonium hydroxide to 3M sulfuric acid. So it's a little bit hard to see, but if you look very carefully, you can see some very tiny bubbles forming in that vessel. Those are not mixing bubbles, those are actually generated by the addition of those two chemicals. And the temperature of this system is definitely above room temperature. I would say this probably feels like it's about probably like 10-15 degrees above room temperature, maybe even a little bit warmer than that. So a definite reaction occurred in that system. Like I said, note that there are actually bubbles generated, so that should tell you what happened during that reaction. And now we're going to put the sulfuric acid away and the ammonium hydroxide. We're going to move through to the 8th pair in this system. And we're going to mix 0.1 m sodium carbonate with 0.1 m calcium chloride. So there's our calcium chloride. And our sodium carbonate that we already used. They're both fairly dilute systems, so it doesn't really matter which way we add these. I'm going to add the sodium carbonate first since I already have that handy. Then we'll get a clean pipette. It's the first time we've used the calcium chloride. And then we'll add this while it's in shot for you. You can see that as I add that, you start to see a product formed. It's hard to see exactly, but what you're really seeing here is another one of those reactions where you probably have a solid formed in a liquid system. We're going to put these two away, and then we're going to run our next pair of reactants. We're going to use copper 2 sulfate and ammonium chloride. So we need a couple of clean pipettes for this. We'll add the copper 2 sulfate first. Actually, we'll add the ammonium chloride first. No real reason, but if we add a blue liquid to a clear liquid, if there are changes, it might be easier to see. And then we're going to add the copper 2 sulfate to this one. Now this is a big bottle, so I'm actually going to pull out the liquid into my pipette here. I'm going to rest it inside the test tube there so that we can add this on shot. So when we add the copper 2 sulfate to the ammonium chloride, we don't really see anything happening. A little shake just to make sure. No, we still get a very pale blue that is attributed to the copper 2 sulfate system, but other than that we don't really see any reaction occurring here. So that was the addition of ammonium chloride and copper 2 sulfate. Was number 9 in our reaction set. Now we're going to add the 0.1 m sodium hydroxide to the 6 m nitric acid. So we already used the 0.1 m sodium hydroxide, and we're going to have a new reactant in the 6 m nitric acid. I'm going to get a new pipette for that. Since the nitric acid is that much stronger, we're going to add the sodium hydroxide first. And then we're going to add the nitric acid to it. We'll try and put this in shot again. We'll see if anything happens when we add the nitric acid to ammonium hydroxide. So there's definitely some cloudiness there, usually indicating a reaction of some kind occurred. Doesn't feel particularly hot. Wouldn't have expected much cloudiness, but it would appear some reaction occurred there. That was the nitric acid and sodium hydroxide. And in our final mixture, we're going to take iron 3 chloride and mix that with 6M ammonium hydroxide. So we'll take our iron 3 chloride and our 6M ammonium hydroxide. We're going to put the ammonium hydroxide in first. And then we'll add our iron 3 chloride. Iron 3 chloride is toxic and it will also stain your skin in a nice bright orange color. So definitely recommend gloves with this as well. See if we can get this in shot as we add it. Give that a little shake. It's a little hard to see at first, but you can see clearly lots of solid forming around that test tube. And in the bottom, you could almost see it forming as it went in if you look carefully at the addition of that iron 3 chloride. Alright, and that will be the end of our double displacement reactions. So just as a quick review of those reactions so we can take a look and see. First of all, we'll look at the front rack, which was numbers 1 through 6. Number 1 was clear. Number 2, we can see there's something at the bottom of the test tube there, so it probably formed something. We still see a few bubbles in here in number 3. Number 4, this one was kind of a surprise because I wouldn't have anticipated any kind of cloudiness here. So I had some concerns about the reagents. So what I did was I made fresh reagents. We're going to come back and we're going to rerun number 4 because that didn't seem to perform as expected. Number 5, at first this just looked kind of milky, but now you can clearly see what is formed in that system. Number 6, this was barium chloride and sulfuric acid. The next one we ran, I'm sorry, number 6 was not barium chloride, that was the ammonium hydroxide and sulfuric acid. So when you look at that one, just make sure you look very carefully at what you see in that. The next one we ran, again, you can see here that clearly at the bottom there's something there. Here's our copper sulfate one with the ammonium chloride. Then we mixed sodium hydroxide and nitric acid. As you can see, again, this was cloudy as well. And this is where in science you have to just really pay attention and take good observations, because again, I personally wouldn't have expected a reaction here, or at least not a visible reaction like this where the solid formed. So since we had two reactions now that didn't occur as expected, so the first one was sodium hydroxide and hydrochloric acid, the second one was sodium hydroxide and nitric acid, I had a suspicion that the sodium hydroxide system wasn't pure, or it was contaminated with something. So we'll come back. We're actually going to rerun both of those in a moment. Here's the iron 3 chloride system that we ran, and we saw a lot of solid form right away. So you should take a note. When you take a note of solids and things like that, don't just say a solid formed. You should be noting what color the solid is. So in this case, what color is the solid, what color is the liquid? In other cases where we had solid form, so if I just pull one of those back up, you can look at that. And you wouldn't just say a solid formed, you'd say what color the solid is and what color the liquid is that's around that solid. We refer to that as the supernatant. So that supernatant liquid in this case is clear, and what color is the solid? Sorry, it's colorless and clear. What color is the solid? So we're going to rerun our two sodium hydroxide reactions. We're going to use a fresh sodium hydroxide system. We're going to run it with the 6M-HCl. We're also going to run it with the 6M-HNO3, or the nitric acid. So the first thing I'm going to do is, since I'm going to run both of these back to back, I'm simply going to use a clean pipette to make sure my pipettes are not the problem. And I'm going to add 1M sodium hydroxide. So this is a little stronger, so if there's a reaction, we'll definitely see it. And I'm just going to add that to both of these test tubes at the same time, since we're going to be running that pretty much in parallel. Then we'll do them in order. We did the hydrochloric acid first, so we'll do that one first here as well. So this is reaction number 4 that you ran. This is sodium hydroxide with hydrochloric acid. So I'm going to run exactly the same system. We've just got the fresh sodium hydroxide, and we'll see what happens this time. So you see the mixing is pretty clear, but this time we don't see that cloudiness that we saw the first time. So it looks like my supposition was right. The sodium hydroxide might have been contaminated with something that was giving us precipitate that it shouldn't have done. So when we added sodium hydroxide with 6M hydrochloric acid, this time it stayed clear. I'm going to touch it. It is definitely a little bit warm now. Since we're using a stronger NaOH system, that is not too surprising. So a reaction occurred in some way, but it was not a visible reaction. There was no gas or solid formed. So you may want to think about that as you work through your reactions. And then we're going to rerun the second one, which was the nitric acid one. So we're just going to try and keep that in shot again so you can see as I add the nitric acid what exactly happens. And again, you see good mixing, but once again, clearly no precipitate this time either. So I think this confirms quite clearly the sodium hydroxide was impure. There's no visible reaction in terms of solids or gases, and it does feel a bit warm again. So both of those reactions with the sodium hydroxide do in fact create a system that gets a little warm, but there is no precipitate. So you can see clearly the difference between the original HCl reaction and the one with what should be now the cleaner, purer sodium hydroxide. And if we look at this comparison the same with the nitric acid, you can see too in that instance now this is what we expected to see on the right. So you can change your data, or what you really should do is write it out that you reran the reaction because there was potential contamination of the sodium hydroxide, and in actual fact here's what was seen. So it's better not to just ignore data, it's better to actually write why data was rerun if necessary, and then what the expected outcome was. And so that's what we see here.